Let's visualize taking the region and rotating it around the y-axis. For this example, I would say the washer and the shell method have about the same level of difficulty. So let's start by visualizing a sample shell. I went ahead and picked a sample x value on the interval from 0 to 2 to draw my shell height. Notice that the height of the shell is parallel to the axis of rotation. Keep that in mind, shell parallel. Now let's go ahead and draw the entire sample shell. Here is our sample shell. It looks like a hollowed out cylinder. Again, we can see the height of the shell is parallel to the axis of rotation. And so we can find the height by doing top minus bottom. So we have that h is equal to 4x minus x cubed. And then the radius is found by doing right minus left. So the right side down here is this generic x value, and the left side is the axis of rotation, which is at 0. So the radius here is just x. Now let's set up the integral using the shell method. So our volume v is going to be the integral from x equals 0 to x equals 2. So our region lies along x values from 0 to 2. Remember, we picked a generic x value in that interval. And then the formula for the shell method is 2 pi. And then the radius, well, the radius as a function of x was just x. And then times the height, which we said was 4x minus x cubed dx. So we can again, try to visualize all of the different shells. This was one sample shell that they are going to be extending from x equals 0, again, rotating around the y-axis, and then moving along the x-axis, getting closer to 2. So let's draw one more sample shell just to make sure we really understand and can visualize. So at this random x value here, I've went ahead and drawn a shell height and then drew my sample shell at that particular x value. So hopefully we can visualize a little bit more what the solid would look like using shells as cross sections.